This video is about the nature of roots and how to form a quadratic equation from roots. Okay, so first of all, what is a root? A root is when the graph crosses the x-axis. And at these points, the x value at these points give us the roots. So for our graph on the left, the x value, the roots would be about x minus 3.4 and x would be minus 0.6. 0.6. Okay, so these would be the roots for these for this equation, yeah, and it also means that at that point, and for those x's, the equation would be 0, yeah. So the y value would be 0. So for x minus 3.4 squared plus 4 times minus 3.4 plus 2, that should give us 0. So if you put this into the calculator, you would get about minus 0.04. So that is about 0. So we didn't read it completely accurately, yeah? So the root is where the graph crosses the x-axis, and also the root is the x value that makes the whole equation 0. And for quadratic equation, we can have either 2 roots, 1 root, or no root. Okay, so let's have a look at the graphs up here. So we have the first situation, the graph on the left gives us 2 roots. Then the graph in the middle gives us 1 root. And the graph on the right has no root. That actually means the graph on the right, for absolutely no x value, is the equation ever gonna be 0? Yeah, so there's no solution for the equation 0 equals x squared plus 4x plus 6. It has no solution. For no x is this equation ever going to be 0, yeah? And we can see that from the graph, it does not cross the x-axis. It's above the x-axis. And for the middle one, there's 1x that will give us a solution that makes the whole thing 0. And on the left, there's 2. So how can we find out whether, if we just look at the equation, can we find out whether we're gonna have 2 roots, 1 root, or no root? So for that, we would look at the minus b formula. So just write it out again. So x equals minus b plus minus and the root of b squared minus 4ac over 2a. So, and what we look at specifically is just this portion. Yeah, so if this portion is negative, if you put that in the calculator, your calculator will say error, because we cannot take a root of a negative value. Yeah, so we cannot take a root of a negative value, and your calculator will say error. If this value is positive, we get 2 x's. We get an x if we add it, and we get an x if we take it away. So so for the plus an x and for the minus an x. And if that whole thing is 0, we only get 1 x. Yeah, because plus minus 0 is the same. So that's why we can use this part of the minus b formula to decide how many roots an equation will have. Okay, so we'll look at the first one. For our first one, the a is 1, the b is 4, and c is 2. Yeah, remember this is a, b, and c. So I will just calculate this part here and find out, is it greater than 0, is it equal to 0, or is it less than 0? Okay, so b square would be 4 square minus 4 times 1 times 2. So that would be 16 minus 8, that is 8. And 8 is greater than 0. And as we can see here, we have 2 roots. So as we see, 2 real roots. For the second one, the only thing that changes is the c. Okay, so we have an a equals 1, b equals 4, and now the c equals also 4. So we calculate the portion under the root. So b square minus 4ac, that would be 4 square minus 4 times 1, and now we say times 4. So that would be equal to 0. And if it's equal to 0, we say we have 1 root. Okay, so we say it as we see it as 1 root, but what we really see is 2 equal roots. Yeah, so 2 roots in the same spot. So we will see later why this is important. Yeah, so we see 1 root, but we call it is 2 equal roots, 2 roots in the same spot. And for the third one, we have a equals 1, b equals 4, and c equals 6. So a equals 1, b equals 4, and now we say c equals 6. Okay, so I calculate that now. That would be 4 square minus 4 times 1 times 6. And what we get here is 16 minus 24, it is minus 8, which is less than 0. Which means we have no real roots. But what we do have, and we will learn later how to do that, we will have imaginary roots. So that is, we'll do that in the complex numbers chapter. Yeah. So don't worry about it just yet. But so we have no real roots. Instead, we will have imaginary roots, and we will learn later how to calculate those. Okay. So to summarize, we have our b square minus 4ac, and this will determine how many roots we will have. If this is greater than 0, we will have 2 real roots. If this is equal to 0, we have 1 root, but really what we have is 2 equal roots. And if this is less than 0, we have 0 real roots, but we will have imaginary roots. Imaginary roots. Yeah, in the complex number realm. So this b square minus 4ac is what we call the discriminant. Discriminant. Okay, so let's we can use these roots now to form an equation. So let's say we have two real roots. Let's say one is at -1 and the other one is at 2. We can use this now to form an equation. So if we can, you can see that, you can double check that again in the factorizing chapter. But if, or in the chapter solving quadratic equation. But if the root is minus 1, we can form a factor that is x plus 1. Yeah, so we can go from root to factor. Yeah, so minus 1 gives us a factor is x plus 1. As you can see here, we have changed the sign. And if the root is 2, we can form a factor that is x minus 2. So remember, we have to change the sign. So if we multiply this now, we get y equals x plus 1 times x minus 2. Yeah, so we can multiply the two factors. If we multiply them out, we get x squared plus 1x minus 2x minus 2. Yeah, we can multiply it out that way. And then we simplify it. So x squared minus x minus 2. So that's how we have used the roots to form factors. To form factors, and then from the factors we can form our equation. So now I want to go back to the situation where it just touches. Yeah, it just touches. So essentially we said we have one root, but it really is two equal roots. And why that is, I want to show now. So let's say that is the point 3. So if we have a root that is 3, we will form a factor that is x minus 3. But because we have two equal roots, we can only, it looks like one, but it is two equal roots. So we'll do that twice. So we need to do this twice, and then we multiply out our factors. X minus 3 times x minus 3, or we could also write it out as x minus 3 and all squared. And so we have then x squared minus 6x plus 9. Yeah, so that's why we talk about two equal roots, even what we see is only one.